So, my name is Ferenc Csonka, and I've got around 40 minutes to speak about automated machine learning in Synapse, so let's jump to the details. First of all, who am I? I'm speaking from Budapest, Hungary, from Central Europe, and I've got a PhD from computer science. I did it around 20 years ago when I was working as a photorealistic rendering computer expert. And I use Monte Carlo simulations and Monte Carlo calculus and several topics, which is really overlapped with artificial intelligence and machine learning. So this is my scientific background about this AI stuff. In the last 20 years, I'm working as a software developer nowadays, mostly with Power BI data analytics and data engineering stuff. And let's jump to the details. What is this automated machine learning, or the abbreviation is AutoML? So very, very typical things nowadays. Everybody is speaking about machine learning, AI, etc., and we need a lot of data scientists, professional data scientists who are able to write Python codes and use the different open source or proprietary machine learning libraries. But at the end of the day, there are several use cases where we need just a good enough machine learning model, which could be used for an ad hoc business decision, or just create a proof of concept to find out it is worth implementing a very, very good model, or this whole approach is not so important. So to do such use cases, nowadays automated machine learning is a really hot topic for professional data scientists and also for citizen data scientists. And what is it, the goal with this whole automated machine learning? So a machine learning process has feature engineering, model selection, or hyperparameter optimization, then analyzing the result of the model, then deploying the model to the cloud, maybe just to be able to use in other applications. So there are a lot of stages in this machine learning process. And the automated machine learning would like to target 1, 2, 3, maybe multiple or all of these stages. So a very quick overview about the history of AutoML. When I did my PhD, it was the very first time when I heard about in research papers that the hyperparameter optimization should be done automatically. I have to say, when I would have been really glad at that time if I have something like this. But at that time, I couldn't reach something which is hyperparameter optimization, which is not manually done by me, rather an automatic algorithm. The very first feature that we could say that it is part of the automated machine learning stuff, automated feature selection, is only in 2024. And the very, very first full model selection, which means that automatically we could create a model which is the best within a reasonable time frame, is only appeared in research papers in 2009. So only more than 10 years ago. The very first workshop which speaks about AutoML algorithms, maybe a competition between different algorithms with different people using AutoVeca, it is an open source tool. It was only 7 years ago. So the whole automated machine learning has a background from the 90s, but in reality it is not more than 6-7 years old technology. And nowadays there are tons of frameworks and tools, open source and paid versions, and one of the paid version is Azure AutoML. What is the Azure AutoML? It is part of the Azure machine learning stuff. It helps this automated machine learning story. It could be useful for professional and, as I previously mentioned, non-professional, so citizen data scientists. And a very short introduction how it works. So you could imagine that you have a data set. From this data set, you would like to create a good machine learning model to do some prediction estimation using this model. So what kind of input I should give for this AutoML? I should give, of course, the dataset and some additional configuration and constraint. For example, I would like to pay for 3 hours to find out the best model within 3 hours, or I would like to create a regression or classification algorithm, or I would like to optimize my model for this metric, etc., etc. There are some configuration input parameters, and then this whole thing like a black box starting, and there are two very distinct parts of this whole process. The first is the feature engineering, and the second one is the iteration itself. So first, what is the feature engineering mean? So I've got a data set. Maybe this data set has some features. If somebody doesn't know what does it mean feature, you could imagine a database table and the columns are the features or attributes or whatever. There are a lot of names for it. So maybe in your data set, there are some columns, there are just some features which has missing values or high cardinality, which means that this column has too many unique values, or there could be imbalanced values. You could imagine a lot of different problems with the data set, and you have to know that the machine learning algorithms are really sensitive for bad data. So that's why if you just start a machine learning algorithm to implement something, a machine learning process, one of the first steps is to do some data cleansing and do some additional steps to have a good data set for different kind of algorithms. So this very first step to find out what are the best features and to modify this data set to have a really good model for it. We need this feature engineering, and this is automatically done by the AutoML stuff. Then the second step, after we have a good data set for the model selection, then you could imagine it is an iteration process. In one iteration, he will select one algorithm, for example, gradient boost machines, and select an appropriate hyperparameter for this algorithm. And using the hyperparameters and using the algorithm, he could do some trainings. And at the end of the training, he could say that, for example, if this data set, a part used as a training data set, another part of the data set used as a testing set. So based on the training set, he is able to create the model. Then from the testing set, he is able to check that what is the goodness or accuracy or whatever metrics you select. He could score that this algorithm with this hyperparameterization, for example, it's only good for 53%, and maybe another iteration with another algorithm with another hyperparameters is 95% good. So after the time frame that I originally estimated or suggested for the whole AutoML process, I could have lots of iterations, lot of results. And based on the results, I could find out what is the best model within this time frame. And this will be the best model, which is generated automatically with this process. What kind of algorithms are available, or what kind of use cases should we use this AutoML? Typically, we use the so-called supervised learning. What does it mean, supervised learning? If somebody heard about this, there are other categories in machine learning. So unsupervised learning or reinforcement learning are also big classes within machine learning stuffs. But the AutoML typically, not always, but typically focus on supervised learning. What does it mean? For example, in 2015, Danny Lang, who was CTO and head of artificial intelligence in very small companies like Apple or Amazon or IBM or whatever. So Danny Lang mentioned that if your company has some historical data in a tabular format, for example, for the data from the last 2 years, then please use this data as a labeled data, which means that you know that in this table, in this historical data, this and this feature generates this value. For example, if this data is you have a data set house sales, so different houses, different sizes of houses, locations, etc., and the price where you was able to sell this house, then this is a historical data. And because this is a historical data, it is also a labeled data. For these features, I have this labeled price. Then based on this historical data, you could start to use supervised learning because as a labeled data set, because then you are able to predict for other houses what could be the estimated, the predicted price to sell this house. So I believe for such scenarios that Danny Lang also mentioned, to supervised learning, to have some historical data in our companies, and it's really typical in a business that we have some tabular historical data. We should use it as a labeled data and then use this labeled data as predicting some estimations. For example, sales forecast, churn prediction. Today we will have the second example is a churn prediction, profitability prediction, etc. And within the Azure machine learning or AutoML, there are three big categories. The classification, the regression, and the time series forecasting. Classification means that you would like to predict that, for example, this is a dog, this is a cat, or this is another animal. This is the general classification. If the outcome is only two values, we are speaking about binary predictions. For example, this will be the churn prediction. This customer will be churn or not churn. This is the binary prediction. Regression means that you would like to predict a continuous value and numeric value. For example, you would like to predict the house price if you would like to sell this house. And time series forecasting means that it would like to take into account that some time-dependent part of the forecasting. For example, you have an ice cream company and you would like to sell ice cream, then you should use time series forecasting for your sales revenue, because it will be able to say that during the summer you will sell more ice creams than in winter. So you see that time dependency, seasonality could be used in the time series forecasting. So these are the main categories in ML techniques that is supported by Azure AutoML. And after this short introduction, let's jump into the Synapse and take the first example. The first example will be very similar to the thing that I mentioned earlier, the house price predictor, but now we will do something else, used car price predictor. So I just downloaded a data set from Kaggle. If somebody doesn't know what is Kaggle, it is a company where they have a lot of open data sets because they just starting different competitions for data scientists and find the best data scientist teams or guys and algorithms, etc. So they have a lot of data sets. When you would like to play with AutoML or any kind of machine learning stuff, I highly recommend their site. So I just downloaded the used car data set from their sites and do some filtering, because there was very old cars and very cheap and very expensive cars. So I just created a filtered data set with 80,000 records, which are good information that this kind of car with this odometer value, so how many kilometers in this car, etc., I've got a selling price. And then I've got another 1,000 used car without an estimated predicted price. So we will create a predictor for this 1,000 used cars. And because I would like to predict a value, a numeric value, this is a regression model. Before I'm jumping into the Synapse, I just would like to highlight how it works in high level in Synapse. So as the previous speakers also mentioned, that in the basis, in the foundation, there is this Azure Data Lake Storage Gen 2, and a typical data lake, I have to say. And on this data lake, we will store all the information that is needed for this prediction. For example, all the input files that is downloaded from Kaggle. Then we will use this storage for storing the data in the Spark tables, and also the machine learning will also store some information in this data lake. So after you have this data lake and you open your Azure Synapse Analytics service and you create a Synapse workspace, today you saw in several times that Synapse workspace contains different SQL pools, Spark pools, Synapse pipelines, and all the other stuffs. So we just create a Synapse workspace, and via the linked service, we are able to access this data lake storage, and we will use it for our workspace. And within this workspace, in our first example, we will open an Apache Spark for Synapse. If somebody saw Simon's brilliant session previously, it is a vanilla Spark engine, which is not absolutely the same with the Databricks Spark, which is a proprietary and with several premium features. Now we have this vanilla 2.4 Spark versions Spark. We will use the Spark to load the input data which was downloaded from the Kaggle, and also we will use this Spark for storing the data in Spark tables, and also it will be used for other situations in this AutoML topics. What is the other situation? We will use it for the whole AutoML process. So when you will see that AutoML and machine learning, everything will be visible in the Azure Machine Learning Service and within an Azure Machine Workspace, and the data stored somewhere in the data lake storage. But in reality, the processing, the data handling, and all the machine learning stuff will be run on this Spark pool within Synapse. What does it mean? So in the background, in order to do this demo, or if you would like to do this AutoML stuff later, you have to create not just a Synapse Analytics workspace, not just an Azure Machine Learning workspace, but in the background using this linked service technology through a service principal, you have to connect these two workspaces, and then if you are creating a notebook and write some Python code, it could be connected to the machine learning workspace and do the automated machine learning stuff on the Spark itself. So this is the high-level architecture of this demo, and I'm just jumping to the Synapse. So this is the Synapse that you saw during the day. I'm in the data tab, and the data tab has a dedicated SQL pool, and I have, of course, the serverless SQL pool, and I got a Spark pool with the smallest Spark engine that I could create in Synapse today, and I loaded some data. For example, this is the Kaggle data with prices, and this is the Kaggle data without prices. And the very first step is that I'm just going here and say that this menu point is visible because I created this connection between the Azure Machine Learning workspace and the Synapse workspace using this service principal linked service. So if I'm doing this, I have this machine learning menu point, and in this machine learning menu point, I have a feature enriched with new model. And then I could say that this is my workspace, this will be the name of the experiment, please name the best model that you found within the time frame in this way. And what I would like to predict, I would like to predict the price of the used car. And you see that the whole machine learning stuff will run on my Spark pool. And then I have to determine what kind of algorithm should be used, because I would like to predict a numeric value. It is a regression model, continue. And then I have to find that what is my primary metric that could be used for this whole topic. For example, I just select R2 score. I have to say how many hours I would like to take to find a good model for me, maybe 3 hours. Concurrently, how many iterations could be run? It is 2, because I have a very small Spark pool at this moment. And later in the second example, I will explain what is this ONNX computation, and then I could start a run and it will start the whole AutoML topic. In order to understand what is happening, I just open it in a notebook, and let's check what is this notebook. If somebody didn't see Simon's topic or previous sessions, here is a very interesting thing. This is a Spark pool, which is automatically pause. So at this moment, this Spark pool, this demo Spark pool, is not running. When I click on, for example, Spark, run or any cell, I click on the run button, it will first warming up the Spark, it will spin up the Spark engine, and then it will be able to execute something. Okay, so if just going through very quickly, I just see that it will be somehow connect to the Azure Machine Learning Workspace. This is the subscription, this is the resource group, this is the workspace name in the machine learning, and this will be the name of the experiment that I'm doing using this AutoML technique. And then this is the Spark table where I have the data, the used cars data with prices, and using this line, I will load this data to the machine learning frame. And then the most important stuff is that I will configure how I would like to execute this automated machine learning stuff. So regression model, I would like to predict the price using this metric for 3 hours, 2 concurrent iterations, etc. And then here at the end, you will see that we will use ML flow through the Azure Machine Learning, that after I've got the best model, I would like to register this best model in the model registry to be able to use it for further reasons. So if I just click here, it will start and run a very long process to find the best model. I have to say I did in the develop UI a bit more different version. I just started with the generated notebook, but I did 1-2 additional modification. First of all, I just did, instead of 3 hours, only a half-hour experiment. In reality, it is not exactly 30 minutes. It's sometimes 35 minutes, sometimes 40 minutes, but around half an hour. And a very important thing, if you, this is a configuration for AutoML. Every configuration item has a default value. If you don't write something here, you will use the default values. For example, one of the default value is that the explainability of the model is false, which means that he won't generate explanation why this is the best model, why you should use it for business decisions. But in a normal business situation, you have to somehow explain and interpret or somehow say to your boss that you should do this business decision because the machine learning model says that this is the best way to do some insights or action. And another important stuff is this validation size. In default, it is 10%, which means that if you have a data set which used for training of the machine learning model, 90% used for training and only 10% to check and test the data itself, the model is good or not good. I believe it's better if we have 80 and 20% split. So then I just say that validation size is 20%. And then everything else is the same. And then I just click on the run all, it runs around 30-35 minutes, and then I've got in the Azure Machine Learning, so I'm just jumping to the other side of the story. I've got this Azure Machine Learning workspace, and within the workspace I have a tab called Automated ML. You see there are a lot of experiments because for this demo I did a lot of different situations and experiments. Here is one of the experiments is about this used car predictors. And you see that this is a run. What does it mean run? So you can say that I'm just creating an experiment for these used car predictors, and within used car predictors, I could execute a lot of different runs, because sometimes I would like to do this kind of run, sometimes I would like to do the data filter for only cars within 2020 maybe, or whatever reasons. There you are able to execute a lot of runs within an experiment. One run is started, as I mentioned earlier, with the featureization. So here in the data guardrails, you are able to see what kind of featureization has been done. For example, he realized that there are some missing values in several features, for example, then he just impute the values with means if it's a numeric field, or other techniques for text values, or he just realized that the model field, the model feature has high cardinality, so he could use other techniques to solve it. And then after he just modified a bit the data set, he executed a lot of iterations, and any iteration is an algorithm and the hyperparameterization. And you see there are tons of different iterations. With here the R2 score is the metric, so you could see that there are different values, and the best one is this stacked ensemble model. You have to know that it's a very, very typical thing that at the end of an automated machine learning model, you will get an ensemble model. What is it, this ensemble model? Ensemble model means it is not just, for example, gradient boost machine algorithm, or elastic net, or a random forest. Rather, he just realized that there are good machine learning models in one iteration, and in another iteration, and then third iteration maybe, and then he just create a weighted average of different iterations, and this is a so-called a composite or aggregated or ensembled model of different iteration models. So, for example, he will create a model for gradient boost methods, another one for random forest maybe, and then he will create a weighted average of the two different iterations. This is the ensemble model. So here again, we have a best model, which is an ensemble model. And this ensemble model, because I enabled the explanation, I could see what kind of explanation it found. And if I just show you very quickly, because I don't have too much time. For example, what are the top features which drives the metric to have the best model? Of course, the most important thing for a used car is how many years in this car. So what is the year when it was originally manufactured? Of course, it is also very important what is the manufacturer. Maybe a BMW is more expensive than a Volkswagen. Or what is the model, how many kilometers or miles in the odometer, etc., etc. So if we enable these explanations, we are able, after the run, after the model is completed, to check everything. And let's go back to the Synapse. Okay, you see that now we have a good best model within this time frame. I have to say not the best, because 70 something like this, the R2 value, which is not bad but not really good, but it's usable for predicting some price. And how can I use this generated model, which is available in this automated machine learning experiments, for my additional table in this Spark pool? You remember that I've got this car without price table. So how can I use it for batch scoring? How can I predict the prices? In the first example, I will show that I will use it very similarly as for automated machine learning. What was the main idea behind this automated machine learning is that we should use the Spark pool. And in the scoring, the batch scoring, I will use the same. So I just grab the data from the Spark table, and the most important stuff, maybe this way, better. So I just use the predict function in the best model. A predict function comes from the MLlib. This is the machine learning library within Spark. So I'm just doing nothing else that use the prediction function within the Spark pool, and I could do the scoring. And if I'm just scrolling down, maybe the screen will be visible. You see that I did the prediction, store the data, enrich with the price, and grab this data and show you in the notebook like here. So here are the different data for the use cars, and here is the predicted price, which was predicted using the best model within the Spark engine. So this is the first example. The main information here is that the automated machine learning stuff could be executed within the Spark, and the batch scoring could be executed within the Spark. The next example is a churn prediction. As I mentioned earlier, churn analysis typically has two outcomes, churn or not churn. So it will be a binary prediction, a typical classification model. Again, I downloaded a data set from Kaggle, which is a telecommunication company's data set with several customers. Customers has a lot of features, for example, uses roaming, how many calls, how many SMS, how many etc. information that is really important for a telco company. And at the end, the most important feature or column in this table is that this customer was churn or not churn. And using this historical data, we will predict another 300 customers. They will churn or not churn. Okay, this is the task for us. And we will use again automated machine learning within the Synapse. Again, a very short high-level architecture. So everything will be the same as previously. So we will grab the input data using the Spark engine. Then we will connect to the machine learning service through the linked service capabilities. We will execute an automated machine learning experiment and run, etc., etc. And then at the end, we will have a model. But the main difference here that we will enable that the model should be in a specific format. It is called ONNX format, which is an abbreviation for Open Neural Network Exchange. What does it mean? It is possible to convert an AutoML or machine learning model to a specific industry standard model, and then you could reuse this model in an absolutely different environment. So not just in Azure, for example, rather an absolutely different environment. Why is it good for us? Because we would like to use this best model within Synapse, but not in the Spark engine. Rather, we will use this best model for batch scoring in a dedicated SQL pool. So in the dedicated SQL pool, we will have these 300 people where we don't know that they will churn or not churn. So we would like to predict that they will churn or not churn using the best model, which is coming from the AutoML experiment. And you will see it is really, again, a no-code, low-code solution, because with some clicks and maybe just writing 1-2 lines code, then you will be able to do this batch scoring within the dedicated SQL pool. So let's go back to the Synapse. Again, to the table. I've got one table within the Spark. This is the downloaded dataset from the Kaggle. These are the customers with churns and not churn data. And I just, again, start machine learning stuff and enrich with a new model. I would like to select what is the field that I would like to predict. So this is churn or not churn. I will use, again, the Spark pool and find out what kind of algorithm should I use, because it is classification. I will select classification, and I could select what is the primary metric, how many hours I would like to execute, again, very, very similarly. And the most important thing for this demo, that we will use ONNX compatibility mode. Again, because I just click somewhere else. ONNX, and it means if I just select this and show it in a notebook at the end of the day, that if somebody just checked previously without ONNX, it was just some lines in this cell that in the ML flow we will register this model within the Azure Machine Learning Model Registry. But if we would like to register this model as an ONNX format model, then we have to convert from the Azure model to the ONNX format, and it is generated with this longer code. At the end of the day, he will register the model, but before he registers, he just creates this ONNX conversion. Here I have to emphasize that not all models could be converted to ONNX. For example, time series forecasting, absolutely not possible to convert to ONNX at this moment. And within the classification and within the regression category, there are some algorithms also which are not possible to convert to ONNX. But fortunately, most of the situation when you would like to create regression or classification, it is possible to convert. And then if I just execute this notebook again, it will execute within 30-35 minutes an automated machine learning algorithm process, and then we will get the best model. At the end of the day, if you just go here, you will see that this is the latest run where I just created this model. If I would like to go into the details, I could see that, okay, the best model is again an ensemble model. As I mentioned earlier, it is an aggregator combined model for composite model from different iterations. And here I just would like to show that because it is an absolutely different category of the machine learning. It is a classification or binary prediction. It has absolutely different metrics. So not typical metrics that is available for regression method, but for example, typically for classification. And to show it a bit more, I will show you as a chart the confusion matrix. What is it? It is something where you could check that your model is good or not good. What does it mean? So every time if he predicts 0, which means non-churned, and originally based on the label data it is not churned, then most of the data was here. So we could predict in good way that if somebody is not churned, then we predict not churned. In the diagonal side, again, if somebody is predicted to churn and originally it was churned, it is also good. So this should be the confusion matrix is good if values are here in the diagonal, or maybe just very small numbers in the other parts of the matrix. You see here, I predicted churn, but originally it is not churn, or actually it is not churn. It's very low number. Here is a number which shows that this model is not the best machine learning model, because sometimes it says that I predict non-churn, but officially, actually, he is churn. If we have more time for finding a best model, probably this will be 0 and this will be 0 also, or very close to 0. And then this model maybe within 3 hours will be a really good model to create a prediction. Okay, let's go back. And what is the result? So we know that now we have an automated machine learning model, which is in ONNX format. And we would like to use it for scoring. And as I mentioned, it is possible to use for batch scoring, not just in Spark engine, but also in the dedicated SQL pool. So I've got just a very small dedicated SQL pool in my Synapse workspace. It has this table which contains 300 different customers. And for these customers, we should predict that churn or not churn. So again, a very low-code, no-code solution from Microsoft that I just would like to, in the machine learning menu, enrich this table with existing model. What kind of existing model? Here, because we have this linked service with the Azure Machine Learning Workspace, he just try to find out, try to gather all the models in this workspace, which is in ONNX format. Any other model is not visible, only those models which are in ONNX format. Okay, so I've got only this one. I just select it, continue. And the next question is that I've got a description from the model, the machine learning model. This is the features, the columns, and this is the output fields, and how I could map these columns to the SQL table columns, because I've used now all the field names are the same, so the mapping is automatically done. If you use different names, that of course you have to manually do the mapping. I just delete this one because I would like to predict only that it is churn or not churn. I don't need the probability. Then I have to enter a store procedure name. At first, when I realized it, I would like to get a store procedure name. I don't understand this, but you will understand immediately. So I will give a name for this store procedure. This store procedure will be able to do the batch scoring. And I have to select a table within my dedicated SQL pool. And what is this table? Maybe it's easier if I just click here and speak about it. So I have got this best model in the Azure Machine Learning Model Registry. So is it in an absolutely different place? But I would like to do the batch scoring within the dedicated SQL pool. If I don't want to move the data from the dedicated SQL pool to any other places, then what is the only possible way to do the batch scoring? I have to move the model itself to the dedicated SQL pool. That's why it is in ONNX format, because in ONNX format, it is possible to import and store and deploy this machine learning model within the dedicated SQL pool. So finally, I've got just a SQL script. I've got a new store procedure. It will move it will do the mapping, and it will. The most important one is this one. It will do the prediction within the dedicated SQL pool using a new SQL command called predict. The first part is getting the model, this ONNX format model, from a SQL table. It is a dedicated table in this dedicated SQL pool. I just named it AutoML models. And within this AutoML models table, there is one record, this one ONNX model. So using this model, he is just grabbing the data from the churn investigate table and execute the prediction, and he will do the prediction in the column called label out. I just execute it to show you the final result. So show it a bit longer. Okay, so here was the original columns, and I have got now a new column called label out. 0 means it is not churned, and 1 is churned. Maybe here is 1, and there are several other rows where I have this 1, which means that this customer, based on my prediction, will churn. So then I could do the decision. I do, for example, a campaign, and maybe this customer will have some discounts or whatever, just to not churn in my business. So this was the second example, and the most important thing here, we need a machine learning model in ONNX format, and then we could do the batch scoring within the dedicated SQL pool. Just to close my session very quickly, all this automated machine learning is good enough or not good enough? I have to say I did some research in this topic, and I couldn't find too much things in the internet at this moment. So a woman in Microsoft built a regression model for predicting the house prices using a Kaggle dataset within Power BI, because Power BI also has this functionality, this automated functionality, and she was able to do a 88% model. Then she did the same dataset and start a Jupyter notebook and write Python code and create a random forest with threefold cross-validation, etc., and she was able to create a 95% model within a much reasonable execution time. So if just compare these two extremes, AutoML is good or not good, what's your idea? I have to say that at first sight, AutoML seems a bit slower compared to a Python developed random forest algorithm. But if you just think more, you don't have to write anything because it is a no-code solution, or you just write some lines of Python code in the Jupyter notebook and maybe it's a low-code solution. If you just think that implement this whole notebook, write the featureization, write the model selection, write the appropriate hyperparameter optimization, and etc., write, solve to get the explanation, etc., you have to write a very long Python or R script or whatever language you would like to use for your machine learning model. It needs a lot of time. So if you just compare to implement a machine learning model within a reasonable time, and it could be good enough, I believe AutoML is really good. And just to close my session, I just did some research. Is there a comparison between the different AutoML libraries like Azure, Google, or open source AutoML libraries? And I have to say there are just baby steps to compare these algorithms. And of course, there is no real research that what is the comparison between a computer and a human, like in a chess competition, but I believe in the next years there will be several comparisons because it is a hot topic nowadays. So my conclusion is that Synapse loves AutoML. And why? Because I could do the whole training within the Spark pools, and I could do the best scoring within Spark or dedicated SQL pool. So all the important part of a machine learning process, the training and the best scoring, could be done within Synapse. Of course, there are other methods to use the generated AutoML model. If you just deploy it to an EKS or Azure container instance, then as a web service, then you could use it from, for example, Power BI or whatever other applications where you could call a web service to predict a value. So this is my session. I hope you have a feeling how the automated machine learning works, what is the goal with it, and what is the use cases when you should use it.
All right, great. I mean, that was